All right, let's go ahead and get started today. Those of you, if you weren't here on Tuesday, Canvas was down during class, Integrity was down during class. This is for the online class also that's listening to this. I did go through and find a presentation from spring of 2015, and it just so happens to cover almost the exact same material that we covered on Tuesday from start to finish, except for the very, very last 5 minutes of class, okay? So what I had to do is go through, edit it somewhat to make it start and stop at the right place. But what will happen is when you, and in the online class it should already be there, but when you go to your Integrity Recordings link here, it's going to look like this, and typically what happens is each new recording is added to the top of the list. Since this recording is dated, the one I'm putting up is dated something March, February, something 2015, it's actually going to be found all the way down here, okay? It's in chronological order. So when you go to look for it, okay, if it's not up here, I'm just reminding you, it's going to be down at the bottom, and it'll say Chapter 5, Part 2 of 3 or 2 of 4, something like that. But again, just in case you happen to miss class or you want to go through and take a look at the calculations again, because we did cover a lot of things in class on Tuesday. It should be up this afternoon. Yeah, I was waiting for the cutting and all of the process of working on it. It takes a long time once you change it, but once they get it up, and I think it may be up on the online class right now, then I'll move it over to this. Also, another announcement is you have a quiz opening today. Okay, so if you go down here on your course page, quiz number 2. It's a time value of money. You're going to have 2 quizzes in this chapter, okay? This is the first one. This covers the first part of the chapter, future value and maybe a little bit of present value. They're pretty straightforward questions. 5 questions. You get 20 minutes to take the quiz. You get 3 opportunities to take the quiz. It opens this afternoon at 2 o'clock. It closes Monday at 11:59 p.m. So you've got today, Friday, Saturday, Sunday, Monday to take this quiz. The other one will probably open, I'll probably open it, depending on how far we get today, maybe Monday or Tuesday, and it'll stay open for 3 or 4 days also. It's a 10-question quiz covering the entire chapter. But this is such an important chapter for you to understand that we've got 2 of our 5 quizzes occurring in this chapter. All right, so I just wanted to point that out. Also, a couple of other things here just to make sure you notice these. On your home page, there's some financial calculator tips dealing with all different types of financial calculators, no matter which one you use. There are some information on time value of money. This is, how to calculate a present value of a mixed stream using a TI-84. So there's just some step-by-step information that I've received from students over the years that I've added here. All right, so I think that is it. Are there any questions? And let me say thank you to anybody who could attend last night. If you did attend and you've got your short summary that you wrote up, and again, just a really short summary. When you leave class today, if you would just put them up here, and I will give you your credit. Also, remember the career fair, which the dates on the career fair are what? March 4th. So which one is the all majors? Okay, so what the 14th is the all majors career fair. Okay, so keep that in mind. For the speaker last night? Yeah, just all I need is just a really short summary. That's fine, yeah. Yeah, if you don't have it now, that's fine. You can just bring it to me at any point. Yeah. And for the career fair, if you go to the career fair, bring me a business card with your name on the back of it. Please make sure that I can read your name. But other than that, we should be good to go. Hopefully everybody in here will get those 5 points per test 1 and test 2, okay? As I said, if you can't do any of that, if you're involved on campus in any other way, if you go to meetings, if you go to other speakers, if you're a member of whatever it is, okay, let me know, send me an email. If you can, wait until you have both of them finished and send me one email so that I can go in and I'll give you points. So it's pretty simple, pretty straightforward. All right, so other questions? You just want to study more time value of money, don't you? I can tell you do. All right, let's see. Where did we leave off? Actually, what I'm going to do is, we went through all of this. Present value. I think we left off, the last thing was talking about a perpetuity. So I think that's where we left off. This is what's cut off the end of the last, the makeup integrity presentation I'm going to post. So I'm going to go over this again just really quickly, just to make sure everybody understands what's happening. All right, so we talked about this on Tuesday. We talked about a perpetuity, and basically a perpetuity is simply an annuity that lasts forever. And so the formula for this, you don't actually need your financial calculator, as it says here. The formula for the present value of perpetuity is equal to the payment or the cash flow that you want to last forever divided by R, which R is the rate of return or the interest rate that you can earn on your investment. So the idea is the present value is how much you're going to invest today. Once you've invested the money, then it's going to earn interest, and you're going to then use that interest for whatever, but you're never going to touch the principal. So if the principal is not changed and the interest rate is not changed, then the cash flow or the payment is not going to change. And so we went through an example, a simple example of if you wanted $1,000 per year forever, and you could earn a 10% rate of return on your money, if you plug the information here into the formula, the present value of this perpetuity, it says you would have to deposit $10,000 today, and that $10,000 is going to earn $1,000 per year in interest forever, as long as you don't touch the $10,000 or the 10%. And we went through an example of creating a scholarship using a perpetuity. I mean, that's how it works. And so if you want to donate money to a university, they're going to invest it in what's called their endowment fund, and then whatever it earns is what they're going to use for scholarships or to supplement professors' salaries or for travel expenses or whatever it might be. This is why when you see, for example, some of the Ivy League schools, really expensive schools, a lot of them offer really, really, really good financial aid packages. And the reason is they've had a lot of graduates. Those graduates are really successful and have made a lot of money, and they have donated literally in some cases in excess of $1 billion, not one person but altogether, back to the university. So if you've got $1 billion to invest and you can earn 4, 5, 6% on that, that creates a lot of money year after year after year after year that you can then use for scholarships, lots of really good financial aid packages, and that's kind of that pipeline approach. And so that's what other universities like Murray State, I mean, that's what we're trying to get to. It's just that whenever you've got graduates making hundreds of thousands of dollars per year or even millions of dollars per year, they're more likely to be able to give larger amounts than, say, somebody who's making 60 or 70 or 80. But again, that's what we're kind of working towards, and that's how the endowment works. We've got a person in charge of the endowment. They choose investments. There's a board that watches over the investments and helps choose the investment, and so it's actually a fairly sophisticated process. All right, now, now this is the present value of an uneven or mixed stream of cash flows. And we talked about this on Tuesday once, and we said we were calculating the future value of a mixed stream of cash flows. And I said the easiest way to do that is simply to calculate the future value one at a time and then add them together. But with present value, we can, I don't know if it's actually simplifying it, but once you get used to it, it does probably make it a little bit quicker. We can use our cash flow register on your financial calculator to enter the cash flows, and then we're essentially tricking our calculator into calculating the present value for us. So I'll show you an example of this. Okay, so here is a 3-period mixed stream of cash flows. We've got $400 occurring at time period 1, $300 occurring at time period 2, and $250 occurring at time period 3. The discount rate is 5%. So one way that we can do this is we can simply find the present value of each one of these, take them back to time period 0. So the $400, we take that one time period at 5%, its present value is this. The $300, we take back 2 time periods, it's equal to $270, $211. And the $250, we take back 3 time periods, it's equal to $215.96. And if we add these 3 together, the present value of this mixed stream is $869.02. That's one way you can do it. The problem is, if you've got 6, 7, 8, 9, 10 cash flows, I mean, you can do it this way, but it gets a little cumbersome, a little time consuming. So an easier way, at least in my opinion, once you've practiced this some, is you can use your financial calculator. Now, before anybody scolds me for my very, very bad presentation skills, I know there's not supposed to be this much writing on a PowerPoint slide. What this is just step-by-step instructions, okay? I'm not going to teach from this, but if you need to go back and take a look at this, it will tell you with your Texas Instruments BA2 Plus, push this button, push this button, push this button. It will walk you through the entire process, okay? If you're using one of the other calculators, if you go, let me pull this back up really quickly. Okay, here we go. Perfect timing. Present value of a mixed stream. So if you have a chance to take a look at this, and I'll pull this up in just a second if you need to take a look at it, but you probably can pull it up on your phone and look at the steps. This should walk you through it. It's just a little bit different than what we're going to be doing with the calculator. All right, so with your financial calculator, now again, this walks you through the entire process, but I'm just going to show you how to do this. So let's go here. All right, so this is where we left off, I think. So I'm going to go through the clear process once I get back to zeros. Second, clear time value of money. Second, clear work. And I just want to check it doesn't matter here, but I just want to check my payments per year. Okay, they're on 1, so that's good. Now, what we're going to use is the CF key. So the CF key, you can see it here, the cash flow register. So if you press this, you may see a number here, you may not see a number here. So what I want you to do, and what this will tell you to do, the instructions is once you press the CF key, you want to press just the second key, and then at the bottom, the clear work key. Okay, that's all. That clears out any old cash flows that may be in here. And as we go through here, I'll explain to you, and you'll be able to see why that's important to do. So we've second clear work, we've cleared old cash flows. Now, what you see here, this is CF0. This is the cash flow that occurs at time period 0. But if we take a look at our cash flows here, notice we don't have a cash flow at time period 0. Okay? So here you see the up and down arrows. We can use the up and down arrows to move around within this function, and you can't get lost. I mean, it's just going to take you back around to where you started. So don't be afraid to kind of play with your calculator a little bit and move some of the arrows up and down, that type of thing. So if we press a down arrow key one time, it says C01. This is the cash flow that occurs in time period 1. And in our example, we have a $400 cash flow occurring in time period 1. So what I'm going to do is just put in 400 and then press the enter key. It tells us at the top of the screen, reminds us, press the enter key to lock it in. If you forget to press the enter key and then move past this, it's going to go back to 0. Now I'm going to press the down arrow key again, and it says F01. This stands for the frequency of cash flow 1. So essentially what this is saying is how many times in a row does this $400 occur? The default is 1, which is where you typically want it. If, for example, we had $400 occurring for the first 4 time periods, we could put a frequency of 4 here and cut down a lot on our inputs. But that's not the case, so we'll just leave it alone. If it's not 1, you do it the same way. You just 1, enter. Press the down arrow key again. We go to cash flow 2. So you can kind of see how this works. We're just using our down arrow key to go to the appropriate cash flow, enter the cash flow at that time period. So this is going to be 300 at time period 2. Press the enter key to lock it in. Press your down arrow key. Frequency is set to 1, which is where it should be. Press the down arrow key again. We get the cash flow 3, which is 250. Press the enter key. And we can press the down arrow key to make sure the frequency is set to 1. And now what you'll notice is if you keep pressing the down arrow key, what it's going to do is it's going to take you 1 period into the future, which is cash flow 4, which should show 0. And then it's going to take you to the frequency of cash flow 4, and then it's going to take you back around to where you started. So you can always go back and check your cash flows to make sure that they're all correct before you go any further. So if I press my down arrow key, there's cash flow 4, which should be 0. Now, the reason we cleared this out is because it's easy to forget that maybe on the last problem you worked, you had cash flows in time periods 7, 8, and 9. But then so you didn't clear it out, you come to this problem and you think, okay, I'm just going to enter the new cash flows over the top of the old ones, which is okay. But the problem is you get to this point and you're like, okay, I'm done, I'm finished. And those old cash flows are still there, and so you're going to get some really strange answers. So that's why once we hit the CF key, we press the second clear work button to make sure we clear out any old cash flows. Now if I press my down arrow key, you'll notice I'm just going right back around. I mean, you can up arrow, down arrow, whatever, you're fine. You can stop anywhere you want in there. Once you've done that, then the instructions will tell us you want to press the key directly to the right of the cash flow key, which is labeled NPV. That stands for net present value. Now, this is actually not a net present value problem because we don't have a cash flow at time period 0. But we're tricking our calculator into thinking it's a net present value problem. So once you press the NPV key, it's going to ask for an interest rate or a discount rate. And in this problem, the discount rate is 5%. So we're going to enter that as a whole number, 5. Press the enter key to lock it in. Now press your down arrow key 1 more time. And it tells us at the top of the screen here, press the compute button in the top left-hand corner to come up with a solution. And the solution should match what we have here, which is $869.02. So it goes through and it just does that for you. So did everybody come up with the correct answer here? I know sometimes people kind of get lost in all the buttons we're pushing and you may get behind. What about my TI-84? You did? Okay. All right. Would you help these other people? And actually, I'm kind of curious to see what this does say, actually. Let me go here. Oh, hell, we got a video here. Okay, so you got a video you can watch. I'm not going to go through that, but it should help you out a lot. I'll go ahead and tell you I did not create the video, okay? Somebody else did, but it should be helpful. All right. That's a nice surprise. Okay, so there we are. That's what we just did. So if you forget, you're at home practicing or whatever, walk through that. It will take you the same steps, okay, step by step. And then this basically is talking about, you can use your calculator to solve for any other missing variables. That's the fantastic thing about your financial calculator is you don't have to, as you would using a formula, you don't have to algebraically solve for any of the other variables. You just put in the 3 that you have and you solve for the 4th. The key here is though, if you're entering a present value and a future value at the same time, because up to this point, we've been solving for either present value or future value. But if you enter both of those, the present value has to be entered as a negative number. Say that again. Present value, if you're entering present value and future value, the present value has to be entered as a negative number. Otherwise, you're going to get on the BA2 Plus an error 5 message, and on your other calculators, it'll simply say you can't calculate it. Because again, you have to have a positive cash flow and a negative cash flow. The negative cash flow is the present value. So if we take a look at this, there's just a couple of pretty simple examples. This is solving for interest rates. So it says, if you pay $78.35 today for an investment that promises $100 in 5 years, what is the annual rate of return you will earn on this investment? Well, here are your inputs. And so let me bring this up. So notice, we've got our present value. This is a negative, so I would put this in as 78.35. And now, to make it negative, you're going to use this key, the plus minus key. You're not going to use this. You're going to use here to make it negative, and then you're going to press the present value key, PV. The future value is 100, so it's positive 100. We'll just press the future value key, and then N is 5. I've got my 3 inputs. I want to compute, in this case, the I/Y. And so it tells us that if we invest $78.35 today, if 5 years later, if it's worth $100, we have earned 5% per year on our investment. And just to show you what would happen if you don't enter this as a negative number, you're going to see this. When that pops up, automatically you're thinking, okay, I should have entered the present value as a negative number. Okay, and a lot of you are going to see this as you practice, but that's okay. That's why we practice. All right. Another simple example. Solving for time. So in this case, we've got a security, an investment costing $68.30. It will provide a return of 10% per year. You want to keep the investment until it grows to a value of $100. How long will it take the investment to grow to equal $100? So in this case, we want to know, how long do we need to invest? And this is actually a pretty helpful calculation also. So if we enter the information that's found here, again, notice we have a present value and a future value. But if you enter this information, and I'm not going to work through this one, but your output, your N should be 4 years. So this is good, and if you're saving for a car, if you're saving for a boat, if you're saving for whatever, and you know the amount that you can save, you know how much you need, you know how much you're going to earn on your investment, you can calculate, okay, how long is it going to take me? So that's actually a pretty nice calculation. All right, what else here? Okay, let's talk about semi-annual compounding for just a second. Now, up to this point, when we talk about compounding, which is interest earning interest, we are assuming that interest is being compounded once per year. And the reason we start out with that is because it's simply easier. I mean, it's a good way to start. But in real life, often it's compounded semi-annually, which is 3 times per year, quarterly, which is 4 times per year, monthly, we could even have daily. There's also something called continuous compounding. Now, I will tell you this, and I think it'll show up on one of the future slides. For test purposes, you're not responsible for anything to do with continuous compounding. Okay? That's more of a theoretical concept. It's not really a real world concept, and so, I mean, I'm trying to make this as applied as possible. It just tends to make students more confused than anything else. So continuous compounding, you can just skip over it in the book as you're all diligently reading through your textbook, which I know you do, and don't worry about any homework questions. By the way, assign homework questions for this chapter. And you can take a look at the sheet I have on the Canvas page, but I would suggest working all of the homework problems. And there's a lot. There's 40 maybe. But that's the only way you're going to get good at this is working problems. So if you work all of these and you want some additional problems to work, come see me. I can find additional problems for you to practice on. But again, all of the homework problems for the end of this chapter. All right, so it's basically saying here that when we're talking about the future value, what's going to happen if we have more frequent than annual compounding? And what you will find out is we work through some problems. Let's see. Which here is a problem. What you're going to find out is that the more frequent the compounding, the greater the future value, all else equal. And that simply makes sense, okay? So that's what this says here, okay? So if you have more frequent compounding, your interest earns interest faster, which means the compounding effect is greater, which means the future value is going to be greater. Now, to use that in the real world, what that means for us is if we're depositing money, if we're searching around for a place to put our money, and we're comparing, say, two banks, one compounds semi-annually, the other compounds your savings quarterly, everything else is the same, you would want to go with the bank that compounds quarterly. On the other hand, if you're borrowing money and you're comparing lenders, one lender compounds your interest that you owe them quarterly, the other compounds monthly, you would want to go with the one that compounds less frequently, which is quarterly, because it means you're paying less interest. So it can work for you or against you depending on what your situation is. And so that's what this is telling us. Now, to do this, it's pretty simple. We're going to leave our calculator set to one payment per year, and we're just going to divide the interest rate by M. M is the number of compounding periods per year, and we're going to multiply N by M. So if we have semi-annual compounding, M would be 2. So we would divide the interest rate by 2, enter it into our calculator. We would multiply the number of years by 2, enter it into our calculator, solve it just like we have. And you can see an example of this here. We've got semi-annually and quarterly compounding occurring. We've got a present value of $1,000, N of 5, and 10% interest per year. And we want to know the future value. Well, this is how we would do this with semi-annual compounding. Notice the present value is not affected. We just put in $1,000, press the present value key. For N, we just manually calculate the 5 times 2 compounding periods per year. So what we're doing, we're converting this to 10 6-month periods. And then for the interest rate, we're taking our 10% interest divided by 2, which means we're earning 5% every 6 months. And we compute the future value, and I don't know what it comes out to, but because I haven't gotten that far. Quarterly compounding, you do the same thing. The present value is not affected. N is multiplied by 4, so we're changing now to 3-month periods. So this is 23-month periods. The interest rate is 2.5% every 3 months. Compute the future value. Once you work through these, I don't know what the answers are, but I can tell you the quarterly compounding is going to be larger, and the reason is your interest is earning interest faster. It's compounding more frequently. So that is why the quarterly compounding is larger, and this is where I mentioned you're not responsible for anything to do with continuous compounding. Okay, so that makes sense, kind of how you handle that. And you don't see that very often, but you may run into this occasionally. Okay. Let's talk about interest rate for just a minute, because the reason we do this is you need to be able to convert between what's called a nominal or a simple rate of interest. and what's called an effective rate of interest. So you can see the definitions up here. The nominal rate of interest is the interest rate written into contracts. If you receive an interest rate quote, that's typically what you're going to receive. Nominal or simple interest does not take into account the effects of compounding. The effective interest rate is the rate that you're actually paying if you're borrowing money, or you're earning if you're depositing money. And the effective interest rate does take into account the effects of compounding. And the way it works is, if we have annual compounding, then the nominal rate would be the same as the effective rate of interest. There's no difference. But if we have more frequent than annual compounding, for example, just what we looked at, semi-annual or quarterly, then the effective rate is always going to be greater than the nominal rate of interest if everything else is equal. Now, we're going to learn how to convert between these two, the two different types of interest rates. There's a couple ways you can do this. One is a formula. It looks kind of nasty, but it's actually not that hard to use, which we can see here. So, I mean, you can use this, okay? This is called the effective annual interest rate. And what we need is the simple or the nominal rate of interest. We need to know M, which is the number of compounding periods per year. So what we're doing here is we're simply taking 1 plus the nominal rate divided by, if it's semi-annual interest, 2, raised to the second power, because M is 2, minus 1. This is a lot easier to use than it actually looks here. So, for example, if we wanted to plug in, now your simple or nominal rate would be entered here as a decimal, okay, unlike on your calculator. And so if we were looking at an example here, and I'll give you a couple more seconds to get this written down, it's going to look like this. So here's 10% simple interest or nominal interest compounded semi-annually. So here's our formula that we just looked at. So now we're just plugging the numbers in. So following the formula, 1 plus 0.10, 10%. Semi-annual compounding, M is 2, so we're dividing by 2, raised to the second power, minus 1. So that's going to be 1 plus 0.05 raised to the second power, minus 1, and you're going to come up with 10.25%. So what this tells us is, it says 10%. So you're earning or paying 10% interest, whatever the situation is. But because interest is compounded semi-annually, you're actually earning or paying 10.25% interest, which, as we saw when we looked at future value, even though that doesn't sound like much, over time that can add up to a lot of money, either for you or that you're paying. Now, fortunately, your calculator has a function where you can convert from nominal to effective. Again, this is the step-by-step process, so I'm going to bring up the calculator and just walk you through it. But if you have to go back and take a look at it, this will be helpful. Now, your interest conversion key is going to be found right above the number 2 key. It says ICONV. And so if we press the second key and then the number 2 key, it's going to ask for a nominal rate and an effective rate, or excuse me, a nominal rate and a discount rate. So in this case, in the example, our nominal rate was 10%. We enter it as a whole number in the calculator. So 10, and then press the enter key. Now we're going to press the down arrow key 2 times. It's asking now for the compounding periods per year. If it's annual, compounding will be 1, but we know what the effective rate would be. If it's annual compounding, it's going to be the same as the nominal rate. If it's semi-annual, it would be 2. If it was daily, it would be 365. So we just enter the correct number here. In our example, it was semi-annual compounding, so that's 2. Press the enter key. Now we're going to press the up arrow key once, and it tells us to press the compute key to come up with the solution. And the effective rate of interest is 10.25%. And if you wanted to, just to verify what I said earlier about the more frequent the compounding, the greater the future value, or the greater the effective interest rate is going to be, the difference. I mean, we could enter quarterly compounding, so M of 4, and compute it. You'll notice it's a little bit larger. If we have monthly compounding, where we have 12 compounding periods per year, we can see it's going to be a little bit larger. So the more frequent the compounding, the greater the difference between the nominal rate and the effective rate of interest. So is everybody coming up with the right answer? All right. Now, let's, okay, good. That's the time. Let's talk about loans for just a minute. And the reason that this is a really good part of this chapter, the reason is most of you are going to be borrowing money, or most of you have already borrowed money. And it's something that if you understand it, you still may have to borrow, but you can borrow in a smart way so that you can save yourself literally tens of thousands of dollars in interest if you understand the loan amortization process. If you don't, you're just what most lenders want as a customer is you walk in, you just ask them what kind of loan products do you have. They're going to recommend the one that's going to make them the most interest and cost you the most interest. But it actually doesn't have to be that way. Now, I'm a former lender, okay? So, I mean, I'm not saying that it's just what you're doing. If you have a customer come in and says, for example, we'll talk about home loans. Should I finance my home for 15 years or 30 years? Well, most banks are going to say, or most lenders are going to say, well, probably 30 years. The reason is they're going to make anywhere from $50,000 to $150,000 more interest if you keep that loan for the full 30 years versus a 15-year mortgage, which I'll show you in just a minute. Now, let's talk about this for just a minute. Definition first, an amortized loan. This is a loan that's going to be repaid in equal payments over its life, typically monthly, although it doesn't have to be. It could be, one payment per year, one payment per month, one payment per week, whatever. But normally, most payments are made monthly. Of the total loan payment, and we're assuming a fixed rate of interest, so the loan payment doesn't change over its life. Of the fixed loan payment, a portion of that payment goes to principal. Principal is what you borrowed. A portion of that payment goes to interest. Interest is what you're paying to use somebody else's money. So the total payment doesn't change, but the portion that goes to principal changes. It gets larger over time, and the goes to interest changes. It gets smaller over time, which is what we want to happen because you want more of your payment going to principal because that's paying down your loan balance. Interest is simply going to the lender because you're using their money. And there's something called an amortization table, which actually we've got a fairly simplified amortization schedule on our calculator, which I'll show you how to use that a little bit later. If you're going to have a long-term amortization table or schedule, go online, type in amortization schedule, and you're going to find 1,000 of them. And you can just punch in the loan amount, the interest rate, the length, and it will show you, for example, a 30-year loan, that's 360 payments. So it will show you with each payment, and after each year, how much you still owe, and after each payment, how much you owe. It's a lot easier to do it online and print it than it is to try it on your calculator, okay? If you're doing 3 or 4 periods, that's okay on your calculator, but it gets a little cumbersome if you're trying to write all of that out. All right, now to calculate a loan, it's really simple. We need, again, 3 variables. We're solving for the 4th. We need a present value. Present value is how much you are borrowing. It's the principal amount. We need an interest rate, and we need an N, which is a number of payments. We're going to be solving for the payment amount. Now, when it comes to loan payments, at least in this class, you're going to have your calculator set on 1 payment per year or 12 payments per year. If we have a monthly loan payment, we would change it to 12. Otherwise, we're going to leave it set on 1. And then this walks you through and shows you how to do that. So if we want to calculate, we'll just start out with an annual payment loan, one payment per year. So we'll leave our calculator set on payments per year equal 1. So here's an example. We're borrowing $15,000. We're paying an 8% interest rate, and we're going to pay it back in 3 equal annual installments. So calculate the payment. Well, let's see. I don't think I have. Let's see if I've got the example. No. Okay. So to do this, now I'm going to just go through the clear process just because I'm in the habit of doing it. I'm set on one payment per year, which is where I want to be. I'm just going to enter the information. Doesn't matter what order. So 15,000. I'll press the present value key. 8 is my interest per year, and 3 is my N. I have my 3 variables. I want to solve for the fourth, so I'm going to compute the payment. And this tells me that I would have a payment of $5,820 per year for 3 years, and I will have paid off the $15,000 plus the interest that accrued during that time. So did everybody come up with $5,820.50? Okay. Okay, so to do this, what I'm going to do is I'm going to just enter the information here. So 15,000 is my present value. 3 is my N, number of payments, and 8, the whole number 8, I/Y. Now press the compute button, top left-hand corner, and the payment key. Does it work? Yeah. Everybody else getting the right answer? Now here's another example, and this may be a little more realistic. Okay, you want to buy a car, and buying a car for some people is a very intimidating process for a couple reasons. One is cars are expensive. The second reason is a lot of times you have to deal with car salespeople. Okay? And if you're in the car business, if you have family in the car business, if whatever, okay, I'm not lumping all car salespeople into the same category, but there are some car salesmen and women out there who would lead you down the wrong path. Yes, they will be dishonest with you. I know that's hard to believe. I know it's hard to think that they might try to trick you into buying a more expensive car or buying things that you don't want or taking out a loan that you don't need, but it's true. But again, not everybody, okay? I've got car dealers that are good friends. Some are honest, some aren't. It's just that way with just about any type of profession that you can find. But with this example, I mean, it can cost you a lot of money if you find the wrong one. So here, you are wanting to purchase, you found the right car. You've been car shopping, and we'll say it could be a new or used car. I'll give you my personal opinion on buying new versus used in just a minute. But you're going to buy a $25,000 car. You actually have a down payment. You saved up $5,000. So you're going to borrow $20,000. The interest rate is 7% per year, and you're going to finance this car for 4 years or 4 times 12, 48 monthly payments. So in this case, if we want to enter this information, so let's see here if I can get this working. Okay, here we go. So the present value, the amount that we're borrowing, is $20,000. The interest rate was 7%. And N is going to be 4 years times 12 months per year equals 48 monthly payments. Now, you want to remember to change your calculator to 12 payments per year. Because you were reading through it and it said you're going to make a monthly payment, monthly car payment, monthly house payment, whatever. Now, some of you may be thinking, if I change my calculator to 12 payments per year, why do I have to go through and do this multiplication process that we did here? Okay? I'm going to simplify it for you because it's a little difficult to explain. But basically what you're doing is, because of the difference between the nominal rate versus the effective rate of interest, when you multiply by 4 times 12, it's allowing you to use the correct interest rate. Now, you could do without that if you went through and calculated the effective interest rate and entered that, but it's typically easier just to do it this way. Okay? Once we have this information, let me clear all of this out. Get a check mark here. Okay, so once we have this information, try some red here. We can calculate the payment, and let me catch up with you here really quickly. This is going to disappear for just a second. I think it's going to disappear. I can find my mouse again. Okay, there we go. Okay. So I'm bringing my calculator up. Let me catch up really quickly. I'm going to change to 12 payments per year. 12, enter. Second, clear time value of money. Second, clear work. 20,000 is my present value. 48 is my N. 7 interest per year. Compute the payment. All right. So this is your car payment. You would pay $478.92 per month. This is called P&I, principal and interest. It doesn't include anything else. For 48 months, you'd have your $20,000 paid off. Now, I mean, it kind of depends on your economic situation. You know, for some people, $478.92 is a really high car payment. For some, it's probably not that high of a car payment. So that's something a decision you've got to make. I will say this: cars are expensive, and you can spend a lot of money on cars. Typically, it's going to be for the average person, it's going to be your second largest purchase behind your house. So in this case, and let me kind of explain how this works. Let's say you came to see me. I'm the car salesman in this case. So you came to see me. You walked on the lot this morning. I asked, what kind of car are you looking for? You tell me. My next question for you is going to be what? Okay, how much do you want to spend per month? What do you want your monthly payment to be? They don't want you to focus on the total cost of the vehicle. They want you to focus on the monthly payment. And that's the exact wrong thing to do. Okay? When you're buying a car, you're buying a boat, you're buying a motorcycle, you're buying an ATV, whatever, a house, you want to negotiate the lowest price possible and then worry about the financing. Because if you worry about the payment, you can hide a lot of stuff in a monthly payment and it doesn't really show up too much. But if you have that extra amount added to the price of something, it's there staring you in the face, and you can see it before it happens. So in this case, you came to see me. We went on a lot. We found the perfect car for you. I mean, it is the right color. It's got the right engine, the right interior. It's like new. It's a used car, but it's like new. And you are so excited, but you're trying to keep your emotions under control. And you need to do that when you go car shopping, okay? I mean, I'll tell you. I have to, but it would be so much better for me if I didn't have to take my wife with me car shopping, okay? Because I'm sitting there, especially for dealing with, well, it doesn't matter, dealers or individuals. I try to buy a lot of cars or trucks from individuals simply to cut out the middleman. And what I prefer to do, this is just my personal opinion, is if I'm buying a vehicle, I'll buy one or 2 years old. It's still got some warranty left on it. But the initial purchaser has taken that big initial hit on the price when they bought that new car, because the second you drive a new car off the lot, it's now a used car. And it drops typically anywhere from 10 to 20% in value the second you leave the car lot. I just can't stand that, okay? There's nothing wrong with new cars. I love new car smells. Some people buy new cars, they trade in every year for new cars. That's fine, I don't care. But that's just something that personally, I just can't do. And it drives my wife crazy. I've never owned a new car in my life. I've owned a lot of cars. I've owned a lot of stuff, period. But I've never owned a brand new car. She's like, why don't you just go buy a brand new car one time? So I told her, made her a promise. If I make it to 75 years old, I am going to go buy a brand new, probably at this point, I'm leaning towards a convertible Corvette. And I'm going to be that old dude driving around in the expensive sports car that pisses everybody off, all you young people. You're like, why is that old guy driving that convertible Corvette? Well, it's because I can drive it, okay? I can afford to drive it. So, 75, convertible Corvette. But to that point, I'm pretty much guarantee you, I'll never have a new car. And again, nothing wrong with it. I'm not saying it's not a terrible thing to do. You can spend your money how you want. It's just if I can save $5,000 or $10,000 and my car that I buy has 20,000 miles on it versus none or maybe 5 miles, it doesn't bother me, okay? So you walked in, we found the car, we came in, we sat down, we went through some numbers, and this is the number that I show you. Now, when you walked in today, you said, I want to buy a car, I want this kind of car, and I don't want my payment to be more than $400 per month. And so when this number pops up, there's an issue. So you tell me, I don't know, I said I wanted it 400 or less per month, and that's 478, almost 479. I don't know. I think I'm probably going to have to leave and think about purchasing this car. I do not want you to leave the dealership. That's the worst thing that can happen. I want to keep you there. So I'm thinking about this. I'm like, okay, I tell you what. You look like an honest person. And I could tell you liked the car. I mean, I could see it in your eyes. You didn't show much excitement, but I could tell you liked it. So let me go talk to my finance manager, and let me see if I can do something for you. So I'm going to go in the back room. I'm going to pour myself a cup of coffee. I'm going to check the score of the game on the television. I'll wait about 10 minutes, maybe 15. And then I'm going to come back in the office, and I'm going to say, man, it is your lucky day. I mean, this almost never happens. But I told him how much he liked the car, and we've had it for almost 30 days. Most car lots like to sell their cars every 30 days. We've decided to work with you. So what I'm going to do is I can cut your payment down to under $400 per month. As a matter of fact, I can cut your payment down to, wait a minute, what did I do wrong? Hang on, let me catch back up. Okay, 60 in 20,000. Present value 7, interest per year, compute payment. I can cut your payment to $396, which is less than the $400 that you walked in here wanting to spend. And so the person sitting there who doesn't understand time value of money or doesn't understand lending, I mean, their eyes get big and they're like, oh, Joe, yeah, I can do that. And so we're going to send you home in that car today. Now, did anything magic happen there? Did I do you a favor by doing that? No. What I did, you saw me put the number in. What I did is I just changed the number of payments from 48 to, I changed it to 60 payments, which is 5 years. That's exactly right. So all I did was spread your payments out over a longer period of time. So now you're going to be paying your car for 5 years instead of 4 years. But for a lot, I mean, I'm talking 80% probably plus people, they're not concerned with that. They're just concerned with if they can pay that monthly payment. And if one of the most important things you can take away from this class is not to get caught in that trap. When I would lend money, I'd have customers come in wanting to buy whatever they were going to buy. Probably 10% actually asked me, what rate of interest am I paying? The rest of them just wanted to know, what's my monthly payment going to be? How long can I spread it out over? What's the longest you will finance a bass boat? What, how can I lower my monthly payment? That's it. But again, over a lifetime, that's going to cost you hundreds of thousands of dollars in interest between houses and all of your toys that you buy if you finance it all. So in this case, I mean, it wasn't magic. It was just extending a loan. Now, if you're working with somebody and they are able to reduce your loan payment, there's only 3 ways that you can reduce a loan payment. One or a combination of these 3 things have to happen. One is you borrow less money. You change the principal amount to a lower amount. The second is you extend the payments over a longer period of time. Or the third is you lower the interest rate associated with the loan. One or all 3 of those have to happen to have a lower loan payment. If they bring you something else and tell you anything different, they are lying to you. Okay? It just mathematically has to be that way. So with this example, and I mean this occurs all the time, I could hide a lot of stuff in this $396 per month. So if I added $10 on there for, I don't know, protection, leather seat protection. So we put on a special spray on your leather seat so that if you spill something on them, they're not going to stain. And it costs $600. Now, if I showed you that up against the $25,000 you're already spending, that would pop out. You'd be like, what's the $600 for? But if I add $10 per month to this car payment over 60 months, that's $600. But you don't really notice it that much if I add it to the payment. So again, you have to keep an eye on this. Also, another thing I would highly suggest, your phones have apps, you can download it, or hang on to this calculator. If you go shopping for something that you're going to finance, take your financial calculator with you. Be able to check the numbers against what they're telling you. If they don't match up, you need to question them about it because they may be adding something in that you don't realize. Okay? Even if, let's say 5 years have passed, you're going car shopping, you're like, oh my, where's my calculator? You're digging through a drawer, you find it. There's no batteries in it. You don't have any batteries to fit. Take it with you anyway. And if you're walking around a car lot and they're talking to you and you look like you're punching in numbers into a financial calculator, they're going to think, wow, this person, they're pretty sharp. I'd better be honest with them. It's the person that walks in with really no sense of what's happening. I mean, it's like, oh, it's my lucky day as a salesperson. I can sell them a car, I can sell them an expensive car, and car dealers make a lot of money on the financing portion of it. So they're going to try to finance you at the highest interest rate possible because, again, that's a way that they make a lot of money. Here's another tip on buying cars. If you're going to buy a car, you can finance a car for a long period of time now. You can finance it for 48 months. You can do it for 36 months, which is 3 years. 48 months, 60 months, which is 5 years, 72 months, which is 6 years. Some dealers will now finance up to 84 months, which is 7 years. When you buy a car, if you're going to finance that car, you don't want to ever ever finance a car for more than 60 months. That's 5 years. And that's pushing it, okay? 48 months is even better. The reason is, what happens is when you buy that car, a car is a depreciating asset. That value starts going down, and it goes down faster than you think. On the other hand, your loan payment, if you finance it for a long period of time, the balance on your loan, it's going to start coming down slowly. So your car's worth this, you owe this much. Now, I understand that when you buy a car, and if it's your dream car, you're thinking, man, I have found the car of my dreams. I'm never selling this car. But human nature being what it is, a year later, 2 years later, you see a different model, something else catches your eye, new engine comes out, new interior, whatever, you're like, man, I've got to have that car now. So you want to get rid of your current car. But if you finance your car for too long and it's worth this much and you owe this much, you're what's called upside down on your car loan, which means you owe more than it's worth. And to solve that problem, there's only two things you can do. One is if you buy another car, you can pay out of pocket to pay off the car loan, the balance that's left, and then finance your new car. Or if you're lucky, if the balance isn't too large, sometimes when you finance the next car, they will add the current balance to that car loan, to your new car loan. The problem with that is you start out even further in the hole when they add your last loan balance to your new loan. And so the next time you go to trade in, you're going to be way upside down or way underwater on your loan. And they probably won't do anything for you the next time. Okay, so again, it's crucially important to understand this. Now, I will tell you that if, and there's a lot of different opinions on this. I was going to say, if you can pay cash for a car, that's probably the preferred way to buy a car. Now, some people are going to say, well, even if I could pay cash, I wouldn't, because I could borrow the money cheaper and I could invest the money and make more on my investment, which means I would be coming out ahead. So if I pay 7% interest and I make 10% on my investment, I'm coming out 3 percentage points ahead. That is true, okay? And some people can do that. A very, very, very small percentage of people can do that. But I would suggest if you have the money, you have the cash saved up, and you're financially stable, so you're not dipping into your emergency fund or anything like that, if you can pay cash, the first time that you do it and you get used to not having a car payment, you're going to love it. Because it's just, I mean, it's nice not to have a car payment. And once you start, it's the first one's the toughest one, because the first one, once you have the cash saved up and you buy it, then you can start preparing for the next car or truck or whatever, but you've paid for this one in cash, so you don't have a car payment, so you can save up more. So the next time you're ready to buy a car, you can pay cash for it. So it builds upon itself. Okay? Now again, nothing wrong with financing. I'm a former banker. I teach banking classes. I teach all about lending, and that's fine. But I'll be honest with you, personally, and I've been very blessed and very fortunate, but I haven't had a car payment in, I don't know, 15 years probably. I mean, I haven't had any kind of payment except for a house payment. And I mean, I'm not saying don't buy stuff, because I like toys. I mean, I really do. I like all kinds of toys. Boats, campers, motorhomes, ATVs, you name it. I mean, I own it or have owned it. But at this point, I mean, if I can't pay cash for it, I don't buy it. It's as simple as that. And again, nothing wrong with financing. That's just my point of view that I think would work well for some of you at some point in your life. Understand right now, you know, when I was in college and I was graduating and going to work, yeah, I was financing everything that I bought just about. I didn't have a choice. But you can work your way past that. Are there any questions about buying a car, by the way? Because I know a lot of you, you know, you're either have a car, or you're going to be buying a car when you graduate. Any questions about that process? All right, if not, then on, let's see, what's today? Thursday. On Tuesday, we're going to buy a house on Tuesday. Okay, so we're going to finish up chapter 5. We've got a few minutes left. We're going to buy and finance a house. Don't forget, your quiz is going to be open at 2 o'clock today. It remains open until midnight on Monday. And I think that is everything. Everybody have a great, safe weekend. I will see you back here on Tuesday.